Hello everyone. We will start in 5 minutes. We are waiting for others to join.
Just a minute, sir.
Hello Venkat Prasad sir.
Hello, sir. I'm just trying to share my screen. Just a
Just a
minute.
second, I will make you presenter.
Yeah, please.
Yeah.
Hope my screen is visible now.
Yes.
We'll start exactly in another 5 minutes, sir.
Okay. We have good attendees.
Yeah. So, can I know the speaker of today's webinar, sir?
Narayan sir.
Okay.
Today's session will be given by Narayan sir.
Narayan sir will start, sir.
Should I start?
Okay. Good morning, everyone. This is Venkat Prasad from Genetics Coimbatore. On behalf of Genetics and Famic Technologies, I extend a warm welcome to all of you for our Automation Studio webinar series. Genetics is proud to be an Indian manufacturer of automation products, providing innovative solutions for various industries and offering didactic systems for technical education. So we established in 1977. Our R&D division is approved by DSIR, and we boast an in-house tool room facility for tool and die machinery. As an integrated manufacturing system certified company, we have a pan-India service facility with over 15 branches across the country and 4 overseas offices in the USA, Germany, Africa, and Dubai. Our global presence includes 300 plus support engineers and 150 plus dealers and stockists, serving over 1,000 OEMs and 17,000 plus direct customers. We are also the authorized distributor of Automation Studio in India, and we are excited to have Mr. Narayan from Famic Technologies with us today to lead the session. So we have a series of webinars planned on various topics throughout this month. If you have any questions, please feel free to write them in the chat box and we will ensure they are addressed. Now I invite Mr. Narayan to begin the session. Thank you.
Yeah, thank you very much for your presentation. So I will present my screen to all of you. Okay, so everyone, welcome to the webinar. So our today's topic is analysis of electro-pneumatic circuit design in Automation Studio EU 9.0. Okay. Manthan, is this session recording?
Yes,
Manthan?
it will be. Yes, it will be auto recorded.
Yeah, okay. So our today's topic is analysis of electro-pneumatic circuit design in Automation Studio E 9.0. E stands for the educational. Okay, so my name is Narayan Susange. So our today's agenda is electro-pneumatic circuit design. Okay, so we are going to explore these things. Along with that, we will explore the illustrated library. After that, section components, the PLC control, the Genetics catalog, pneumatics virtual trainer kit, technical training material. So we can short form we called it as a teachware. And after that, demo files, industrial pneumatics, and finally we will go for the Q&A. Okay. So this is some glimpses of today's webinar. So we are going to discuss this circuit. This is electro-pneumatic circuit design. So this is electrical library design. So we will see this thing later on this webinar. Along with that, we will go. We'll explore this electrical library sectional components like this one through our PEMI technology automation software. So after that, we will comprise the same circuit with using the PLC control. So we can control this circuit using the PLC also. I will let you know how we can do this thing. After this, we will explore the genetics catalog access. So through the online catalog, you can explore this genetics catalog, okay, and you will get to know what are the components they have manufacturing. All these things are enlisted over here. Okay, we will take the example of that circuit using those products from the genetics also. So this is the one of the particular example. After that, we will go for the virtual trainer kit. So here you will find the virtual trainer kit like this one. So students or user can easily go through this trainer kit and they can perform their operations in this circuit. Okay. So after that, finally, the technical training material. So teachware. So I will introduce this thing to you and the demo files. Okay. So before going for all these things, I will go for the corporate presentation. So quick overview of automation family technology, who we are and what we are doing. So we have the 130 plus engineers plus software specialists at our end. We are ISO certified. Okay, we are founded in 1986. And Family Technology Incorporation leading the industry by designing the world-class player-oriented tools in the field of fluid power, electrical engineering, industrial automation, and custom software development. So our main office is in Montreal, Canada, and our the two offices are in Mannheim, Germany, and another in Pune, India. So we have in-house expertise in the software development, engineering, and industrial automation. So in the software development, we will deal with the software engineering, database design, network support, real-time systems. In the engineering, we are dealing with the hydraulics, pneumatics, CAD/CAM, mathematical, electrical, and in the industrial automation, we will dealing with the PLC, SCADA, HMI, process simulation, and robotics. And we are offering the 4 products, mainly the Automation Studio, Professional Education version, and then after that, Automation Studio Live Manifold and Andan Studio. And we have the presence in more than 150 countries. So our main objective is that the long-term relationship with the customer, offering the effective support by the phone, email, or online. We have dedicated representative for each account, and we have a lot of support material available, just like the training videos, demonstration files, quick start guides. I will let you know how can access all these things. Okay, so these are some milestones. So in 1986, we are established. In 1989, we launched HydroSim, NumaSim. In 1996, we clubbed these two to form the Automation Studio, and similarly, we are proceeding like this way. So recently in 2020, we completed our 100 catalog, manufacturer catalog, and 2024, we have launched with the Automation Studio 9. So basically, this Automation Studio is a multi-technology and program thing, and we are covering almost each and everything. We find hydraulic, mechanical, electrical control, electrotechnical, digital electronics, PLC, robotics, block diagram, SFC, ladder diagram, workflow, API, FMEA, teachware, control panels, manufacturer catalogs, BOM, component sizing, pneumatic, hydraulic, just name it, we have each and everything present inside this one. So it fits multiple programs. So here we can see mechatronics department, industrial, aviation, diesel, heavy duty, electrical, robotics, HVAC, marine, automotive. So each and every department is covered by using the software. So what are the key benefits? So key benefits are divided into 3 parts. So key benefits for the students, teachers, and school. So students, what can they do? They can validate the theory study in the class. They can illustrate system behavior dynamically in full color. They can enforce this understanding of the system interaction. They can allow to virtually test all the types of system. For the teachers, what they can do? So they can facilitate demonstration of system interaction. They can enhance teaching and learning by the working on the virtual systems. And also along with that, they can easily integrate into the course content and can be handled by both teachers and students easily. So what the benefit for the school? So school can eliminate the need to purchase the single technology software and can be used to in conjunction with other departments. Limits the purchase of expensive and often inaccessible hardware. Train students on the leading edge tool commonly used in the industry. Okay, so this is one of the best feature from the Automation Studio. So we are offering the license manager. Through that, you can offer the e-learning and remote access too. So remote access can be accessed from the school or home, and through the license manager, you can create priorities for the teachers and students. You can configure time restriction, access points. All these things can be managed through this one. So we have international presence. So we are available in 30 languages in more than 150 countries. So mostly it is being educational version is used in high school, career centers, colleges, universities, workforce development. So these are some of the famous publications. So all the examples present inside these books are available inside the Automation Studio. You will find all these things inside the Automation Studio. I will let you know how you can grab these things. Okay. So interactive exercise, you will find the interactive exercise like the one, it has step-by-step instruction, how to perform each and every operation. So nobody has to worry about how I'm going to do this thing. So with 1 or 2 iterations, you can learn all the things very well. So it has built-in interactive exercises, easy customizable, and create your own. You can create your own also. So digital twin of your own equipment. So take an example of this. If your university or your school have this type of system present inside your campus, you can create a replica of that same thing inside the Automation Studio. And before going for the hand-on experience of this expensive hardware system, the students can perform all the operations on this Automation Studio, and later on they can shift to this hardware thing. So you can duplicate your hardware equipment virtually, change the properties or create the faults for troubleshooting, an easy transition from theories to practice. So this is some examples of the illustrated libraries. So we have illustrated library for PLC, hydraulics, pneumatics, and AC/DC motor contents. So all these things are available. So basically, Automation Studio is the 3 ways to create, simulate, and troubleshoot. So you can create your CAD system, you can simulate the CAD system, and you can even troubleshoot that CAD system using the Automation Studio. So this is one of the best thing offering by the Automation Studio. So this is one of the takeable example I will show you. This is one video. So I will play simultaneously. You will get to know. So you can see what are the operations the trainer performs over here can be performed inside the automation studio in the same manner. Okay, so we'll continue. So this is one of the best example to show you. So after that, what's the benefits of virtual plus hands-on experience? Hardware comes in expensive option. So instead of gathering too many hardware systems, you can gather few and you can gather a automation studio. So it is less expensive option, and along with that, hands-on training with equipment, virtual test, troubleshoot, all these things can be performed in the automation studio easily. And we recommend with the ISO symbol helps with the blueprint reading skill. So students and users can improvise their blueprint reading skill also. So even though the changing properties of components to illustrate the different scenarios can be performed through the automation studio. So it might be possible that it is restricted to some amount of pressure or some amount of thing. Even the student or teacher can go beyond that one. They can create their own circuit and they can show it to other through this automation studio. So we have these are the available manufacturer catalog from our side. So basically, you can see automation studio, Argoites, there is a genetics. You can see here, Eaton, Parker. So we have a lot of manufacturer catalog available. So everyone can access these things. They can drag and drop those components and create their own circuit. Okay. So every component present inside that catalog is verified from our side, also from customer side. So it is, we can say 100% okay to perform or create a circuit at their end. So this is a partial list of the industrial clients. So we are dealing with each and every sector. We can, as I already told you, the aerospace, agriculture, energy, forest, the mining, the metallurgy, transport, system integrators, handling, HR, everything. You just name it. We have the customer from that particular department. So we have also offering the complementary consulting services, just like to develop the configurator for the manufacturers. Just to take example, this is the Hydra Force, this is the Bosch Rexroth, and this is the Eaton. So they are just ask for some services. We offer those services to them. Training, maintenance, and services. So online training at the customer premises, we are providing these things, or automation studio training consultants on specific projects, including advanced topics and concept. If you need this thing, you can directly contact to us. Implementation of client-specific custom components and catalogs, hydraulics, pneumatics, and electrics. So we are, as I told you, we can create a catalog for you if you need. Automation studio interface customization. If you need some customization on your own software, so you can do that thing also. So installation, we are assisting in installation. Integration with the clients, corporate applications, software development and consulting services, and turnkey solutions. Those are the things that are offered by FAMI Technology. So we'll move to the actual topic of our webinar. Okay. So this is the automation studio icon. So how it looks like. So upon opening, you will find the interface like this one. So initially there's nothing present over here. So from here you can open these things. You can see there is a window, a pop-up over here. So you can open the default, or you can open the particular category, just like the electrical if you want. You can open it, PLC, robotics, hydraulics. So there are the templates already created for you. And even though you can create your own template also for your own use. Okay, so today we are dealing with the pneumatic. So you can click on the pneumatic. You will find the symbols template, illustrated components template, and a virtual trainer. As just I told you about the virtual trainers, you can find the templates over here. So students can take this template at his end and they can perform their all the operations. Okay, so I have created already one template for you. So I will open that thing. Upon opening any project, you will find there's a few pop-ups come over here. Just like here on the left side, you will find the library. So this is our library explorer. Okay. Okay, so from there you can activate those things. Okay, and there is another thing is the project explorer. So here you can create a multiple documents and you can create your own project. Okay, on this side. Okay, so here you find in the library, generic library, you can find the hydraulic, proportional, hydraulic, pneumatic, proportional, pneumatic, drive, environment, instrumentation. So this is our latest edition, PID control, all these things. So electrical, digital electronics, ladder, the electrotechnical thing. So there are basically two things, IC and NEMA. Those are the standards we are following. After that, latest addition is robotics. So all these things are available for you. So we can access those things. So today we are dealing with the pneumatics. Just click on that pneumatic. You will find the mostly used the components. Daily use components are present over here. Okay, you can simply click on this thing and drag and drop on this editor box. So basically we call this as editor box. So simply you have to just click whatever the component over here and you have to drag it over here. Okay, so it's that much as simple. When I explore this thing, you will find there are so many categories present over here. So you can find compressors and power units, flow lines, connection reservoirs, accumulators, actuators, directional valves, flow valves, pressure controls, sensors, sequencers. So all the things, whatever the industry comes with. So you can find each and everything present over here. And with the customer demand or user demand, we are just adding those things. If you want something new to them, if you found that okay, we want this symbol or we want that thing, so we are just on that demand we are adding those things inside the this library also. Okay, so we'll find this thing, you can explore these things, pressure sources, all these things over here. Okay, so we are just taking the example of our present take the example from our presentation. So this is our example. I will take a just copy of it, paste it over here. Okay, so how we are going to create a circuit like this? Okay, so I will simply click on the pneumatic. Okay, and I will see that there are some components present over here that similarly look like here. So I will drag and drop those component. Okay, so I need a filter, a lubricator, all these things are present over here. So simply you can go here and you will find the fluid conditioning. In the fluid conditioning you will find a filter. So I have to drag and drop this component first of all. What are the components you are required? Okay, so by this way you can drag and drop all these components over here and you can simply connect those by using these red dots. So simply click on this red dot and the next red dot. So by doing this thing you can complete the connection and you can make your circuit. Okay, so zoom page. So I already created circuit for you. In the statement I will show you by using all these components. I have drag drop all these components from here. Just take an example of this cylinder. So I will take the cylinder from this actuators. If I go into the actuators, double acting cylinder builder, I can simply drag and drop that component over here. Okay. In the same manner, this is a orifice with check valve. This is the directional control valve. So you can take this directional control valve from this category. So this is the 5 by 2. So you can go to 5 by 2. Over here, you can find the same component like this, or you can create your own. By this way, you can drag and drop all these things. So this is the exhaust. You will find the exhaust at start. You can see this exhaust. Okay. So by doing this thing, you can complete your circuit like this way, and you can create this electrical circuit along with this by using the library present over here. So you have to go to the electrical control, and there are two types basically, JIC standard and IC standard. So you can simply click on that thing. So most frequently used components will find over here. Simply drag and drop. Okay, and create your own circuit. So ABC. So along with that, you can create also a solenoid over here. Push. So join these things. Simply you can join those things. You can find that electrical control cannot be connected with the pneumatic. You can see it is not. I'm not able to connect this thing. You will find the red line over here. So this is the advantage. The electrical line is not connected to pneumatic, or pneumatic is not connected to electrical. The same thing happened with the hydraulics too. So by this way you can complete your circuit, and so you can assign this solenoid with this the solenoid present inside this DCB by linking those two things. Okay, so I will start the simulation to let you know how it will look like after getting simulation. So to start the simulation, I will go to here the tabs. So you can find some tabs over here, home tab. So you'll find so many things. You can take the use of those things. So there is edit, there is a view, there is simulation. So inside this simulation, you will find the normal simulation present over here. Okay, I simply click on the normal simulation. So you'll find the circuit is getting started. You'll find this is the colorful thing. So it is showing that there is some pressure present over here. So there's a so everywhere there is a threshold pressure value we have kept. So accordingly, it will show you a color. If there is pressure more than some value, so it will show a red color, or more than that, it will show a brown color also. For the cavitation, it will show the pink color. So all the colors things are available over here. Okay, so I have to perform the operations on this circuit. Okay, so solenoid is connected to this, and solenoid to connect to this DCB. Okay, so by connecting this thing, so I will simply click on the switch S1. Okay, you will find this solenoid getting this is getting actuated. Okay, and it allow the flow from here to here through this orifice. Okay, it is getting extended. Okay, so after that, so take example of this is pushing some object and this is punching something over it. Okay, so pasting some stickers on the we can say the carton box. Okay, so it is push that carton box. Okay, and after that it is pasting that sticker on that carton box. So this is the simple automation circuit you can create using all the symbols present inside the library. Okay, so simply I have to retract it. So I will retract this thing and come back to the original position. Okay, so it's the interaction of the electrical with the pneumatic system. Okay, so our today's topic is analysis of pneumatic electropneumatic systems. Okay, so we can connect electrical thing with the pneumatic and we can perform our operations. Okay, so for the next thing, I will stop the simulation and we'll go to the next thing. So next topic is that our illustrated library. Okay, so I just show you the same thing inside the PPT also. So illustrated library. Okay, so what is the difference of the illustrated library? Okay, you'll find the symbol over here also. Okay, you can find the same symbol, but how it is actually looking like in the industry. Okay, if when some user comes and he just see the symbol, but when he goes to the industry, he is not able to understand, okay, what this symbol means to the cylinder, this symbol means to the DCB, or like that thing. But through this illustrated library, he will get to know that, okay, cylinder will look like this, it will get extended like this. So this is the illustrated thing. So you can see the FRL unit. So this is the filter, this is the regulator, this is the lubricator. How in industry actually it is getting look like. So this is the best example of the all the things. The same manner you can connect those things also. So you have to just simply click the rear port to each other. So it will connect to each other. Okay, by this way. So you can even imagine that three-way fitting, how it is going to look like. The same thing available. So how we are going to access those things. Okay, so when I go here, okay, so open library, if I click on the open library over here, you'll find we have other libraries than the generic. Okay, so you'll find electrical aeronautics, two libraries are separately present over here. DC, all these things, hydraulic, sectional. So at the last you will find that pneumatic electrical components, pneumatic sectional components. Okay, so simply click on it, you'll find those components present over here, and you have to just press OK button. Okay, you'll find this library is getting loaded over here, and you can click on that thing and you will find all the things present inside this compressor and power units. Okay, you simply drag and drop those things for your effective use. Okay, in the same manner, the same fashion we did whatever we did in the generic component, we can do the same thing over here also. Okay, so this is our illustrated library. Along with that library, you will find there is another library present over here. That's a sectional one. So sometimes students are curious how the actual the component look like from the inside. So he can get that look from this one. Okay, simply click on that thing, and from this thing you will find that there is a compressor. How the compressor actually look like. So you can zoom that thing and detail. You can find it is getting how the compressor is working. So this is our shaft. It is connected to external motor and is rotating, and it is compressing the air from here and getting out from through this one. Okay, so I have already created that thing. So through the layer manager, I have managed that thing also. So this is one of the most effective tool for the teachers to use, so they can teach the students in a different manner also. Okay, just click on here, visible and invisible. If I make it visible, we'll find all the components present over here as a sectional thing, sectional components. Okay, take an example of this. This is the FRL unit, how it is actually look like. But when we took the cross section of this thing, the component, okay, how it should look like from inside. So it can give you the glimpse of that thing. So spring, so it is regulating, allowing flow, lubricating that thing. So T-fitting, you can find how the cross section look like. The same for the variable non-return throttle wall. So how it is going to look like. So this is a spring, so it is not allowing flow. So this is a check wall, and this is the orifice. We are controlling the flow through that one. So all these things are present over here. So how the exhaust will look like, the meshing thing present inside it. So you can see this is the illustrated one, and this is the sectional one. Okay, the same thing, just like what we connected, we can connect the same thing from here also. So we can simply click connect those red dots to complete the circuit and to perform the operation. Okay, so those are the things. So we'll go move to the forward. So we will start move forward with the illustrated components. So we can create a circuit like this from the illustrated components. So you can see this is the double acting cylinder, this is the single acting cylinder. These are the two DCBs. You can find there is a symbol imprinted on that thing also. Okay, and I will perform the same operation just like the first one. I will start the normal simulation. We'll find those things over here. You can see the flow is going through this filter regulator and lubricator, and okay, it is allowing the creating pressure over on these 2 points. And after that, if I click on this switch S1, so one is getting activated. Okay, can you see right now there is no green button in lighted. Okay, when I click on this S1, you can see the green button is getting lighted over here, and it is extending the cylinder. Same is applicable for this one. So totally it's a virtual thing, which is very useful for the teachers and students to learn all these things, even though new trainers also who is going to explore the new industry. So for all of them, it is a useful thing to learn what the industry has. Okay, so I will stop this simulation and I will move forward to the next thing, the PLC. Okay, so there is another add-on thing. So PLC, we can control this circuit. Normally we have controlled this thing through the manual version. So right now you can see I have control all these things through the manual. I just have to press the button S1, S2, but I can automate that thing through the PLC. Okay, so how I get to know this, how I get this thing PLC. Okay, so if I go to the same library, if I go to here, illustrated PLCs, we'll find we have created so many PLCs. We have so many manufacturers just like the Allen Bradley, Bosch Rexroth, Eaton, Koyo, LS Electric, Mitsubishi, Omron, Schneider, Siemens. All these things are present with us. So right now I take the reference of the Mitsubishi standard diagram. So you can simply see, oh no, it's a Siemens. Oh, yeah, it's imprinted over here. It's a Siemens Symantec S71200. Okay, if I go to Siemens, here you can see the same thing. Okay, even though you can resize that thing, if you want to get the enlarged view of that thing, you can simply expand it like this way. So it is can be easily readable, accessible. All these things you can perform. You can minimize, you can shorten that thing also. So all these things, all the operations you can perform. Okay, so for this any PLC, you have to create a ladder diagram. Okay, so how you are going to create ladder diagram? So it is already available inside the generic thing. Here you can go inside the ladder diagram for the Siemens. Click on Siemens. You'll find rung, normal open contact. So those are the most useful thing. When you expand this particular thing, you will find the all the things present inside this, all the categories. Just rung, bit logic, timers, counters, comparators, converters, integrator, floating, move, jump, shift, word logic, and the program management. So all these things, whatever the things required for the creating a ladder diagram, you can find it over here. So simply you can drag and drop this rung as it is. You can enlarge this size as per your requirement. Okay, so you can do all these things. You can perform all the operation. If you right click on this thing, you can get some information about that thing. You can log the sites. You can get the component properties also from here. Any association, if you need, you can do that thing. Okay, so all these things are present. Okay, so simply as like I told you in the pneumatics, you can also perform the same thing. So you can simply connect those red dots by click on that points. Okay, so it's like that much simple. Okay, so this is the simple circuit what I created, illustrated from the illustrated library, and this is my run. Okay, so I will go to the next step. So here you can see I have taken all the components from this library. All these things are available here. So you can see, okay, the normally open, normally close, so all these things present over here. Even the thing you can see the output. So everything is present inside this library. So for the reference, I have taken all these things at my side. Okay. Along with that, you also need to know that we require this S1, S2, that's solenoid to actuate those things to get the some supply. Okay. So everything is available over here. You just have to take a look. Okay. You'll find each and everything. Okay. Okay. So I have made these things. I have made the connections in the next step. So you'll find that thing in the step 6. Okay. So I have created all these things. I have created logic. I have linked them in the next thing, next stage with each and everything over here. Basically, what is it? So it has some sensor based thing. So it is going to sense the value present over here. After that, it's getting actuated. It will perform some operations over here and it will give the output to the S1 and S2. So that's a basic thing. Okay. Okay, so you can see there is a comparator also, all these things. After that, there is a standard diagram where I made all the connections. I made all these things present over here. And if I start the simulation, you can see start, stop button, PS1, PS3. So you can see this, there is sensors present over here, PS1, PS2, PS3, PS4, all these things. Those are the sensors. And these are the S1, S2. You can see S1 and S2 over here. Okay, if I start the simulation, normal simulation, okay, I have to click on the start button. You can see it's getting extended. Yeah, it will perform some operation for the time. You can see it is the continuous running process. Okay, so through this you can also create a counter over here. So for that time or for that count, you can create a circuit to run for 100 counts, for the 50 counts, or for the 10 counts. Okay, so you can arrange all this thing through this one. Okay, for the comparators, you can find the green buttons lighting over here, lighting over here. So particular thing is activated or not. Okay, so this is the useful thing in learning and getting used to the industrial things. Okay, yeah, so after that the main thing is that the genetics library. Okay, so you can access the generic library, the genetics library. So how you are going to access that thing? If I go to home button, okay, here I find the online catalogs. Okay, simply you have to click over here and you direct you to the web browser. Okay, so you can see web browser over here. Okay, so here you can find all the libraries or the catalogs we have created. Okay, you can see Argoitas, Aventex, Bosch, Booker, SciPac, Eaton, Hingley, Helac, Humphrey, Headache. Here you can find the genetics also, Cognine, Parker, SMC, Technod, UK. So all these things are here. Okay, so we are today focusing on the genetics. You can click on the genetics pneumatics. Every time it comes with some agreement, so you have to accept that agreement. Okay, so here you can see genetics library. We have covered those things in the step-by-step manner. So air cylinders, directional control valves, airline valves, air preparation units, one-touch fittings, accessories, and new products. Okay, so genetics has their own PDF. Okay, so they have structure in their way. So then the same structure we have created their components through this catalog manager. Okay, we will find those things. Okay, so simply I click on this air cylinder ISO 6431 cylinder. and I can see the components is visible over here. Okay, so it is giving you primary information that it is a standard cylinder A1 to A13. So it will show you that it's a category path. So it's a pneumatic actuator cylinder double acting. So it is manufacturer approved or FAMIC approved. It will give the sign over here. So it will give some descriptive information that it's a ISO 6431 CTOP RP435 RP53 standard double acting non-magnetic low friction adjustable cushioning at the both side. Okay, so that's the information. Okay, even though you can enlarge this thing by using clicking on this thing, so you can see it will show the symbol of that thing. So the part number. So here you can go and you can create a part number through this XML organizer. So simply have to click on these options. You will find magnetic, non-magnetic. So I will click the magnetic. You can see there is a change in the symbol. Okay. After that, cylinder bore, I can select the any cylinder bore 80 as per my requirement. With the stroke, I can go for the availability of strokes, and then after the mounting, I will need the basic mounting. So with this data, it will generate a symbol, a final symbol. Okay, and after that, you will find some properties for this particular cylinder. So what are the properties? So the maximum pressure is 10 bar, the temperature is 60, my minimum operating pressure, piston diameter, rod diameter, stroke, minimum temperature, cushion length, port size, all these things. Even though along with that you will find a PDF. So you simply click on it, it will open the PDF in the next tab, and you will find the information about that product over here also. Okay. So after that, the image, how it actually look like. So you can see in the image how the generator is going to provide the cylinder in which manner. If there is any 3D file, you can find the 3D file here also. Right now there is no 3D file for this thing, so it's okay. So how can you use this product now? Okay, simply I have to go here and I have to drag and drop this product over on this editor box. Initially it will show the red block. It will take some time, and you can see it is getting generated. So you can see we have get two products. Okay, so this is the proximity sensor. Okay, and this is the cylinder one. And you can see that there is a part number here also. Okay, so this is very useful. When I go for the BOM, BOM means basically bill of material. So you will find all the components over here except the lines. You will find all the products. So you can see 5x2 solenoid pilot operated valve with spring return. The quantity is 1. Okay, and then there is direct exhaust, double acting cylinder, FRLM unit. So all these things, even though you can edit those things through his fields also, you can add those fields. I want some other information just like the catalog description, the manufacturer or the part number I wanted from that thing. So close it. You will find the part number for the same. Okay, if that has a part number, you will find the part number for the same thing. Okay, variable non-return throttle valve. So all these things are present. Okay, so this is the thing. So I have created already created this circuit for you by using all the commands from the Genetics online catalog. So all these products are available inside the Genetics catalog over here. Airline valves, air preparation units, the one-touch fittings, all these things over here. Okay. So if I start the simulation, you can find the same thing is going to happen over here. So if I click on the switch S1, it's going to extend. It will extend that thing. Okay. So that's the genetics part. So as I told you, the genetics catalog says how can I access that thing, and after that, circuit is using the genetics catalog. Okay. So next thing, the virtual trainer kit. It's the most useful thing for the students. Okay. So before that, there is another application or another thing I have created for you. So I will close this thing for you. So you can create save those things at your own locations as per your requirements. So it is saving with the extension of PRX. Okay. So PLC sensor. Okay, so this is a small circuit. Okay, so what I showed you with the illustrated one. So this is the generic thing. So you can find the compressor with the motor, all these things present over here. If I can start the simulation, so here I can see there is a HMI button I have provided over here. Just I have to click on this thing to complete one cycle. So it will get extended. S2 is getting sense. Okay, it will actuate and it will get back to the position. Okay, so I can automate that thing also. If I remove this thing, if I put this push button, if I want to operate that thing for the number of time, so it will perform those operations until unless I'm making it off. Okay, can you see these are the sensors, position sensors. By using slide diagram, it is going to perform the operations, extension, retraction, all these things. Okay, then I'm going to close this project. Yes. Okay, so virtual trainer kit, how we are going to access that thing. So if simply I go to this icon, file icon, I will open the new project, and here inside the pneumatic, I will find the virtual trainers. Okay, there are some basic examples already created for you, so you can take any example. Okay, so I will take this electropneumatic on off. Okay, yeah. So this is the basic thing, basic unit. Every university, every colleges has that unit, so they can uh, simulate that thing with the animation studio also. Okay, so they can create their own also, and they can even know that it is available at their side. They can perform those operations at their end. Okay, so before going for these things, so user has to make some connections. Okay, so you can see there are red ports, blue ports. Here also some ports are there. So this is a 24-volt line. This is 0-volt line. Okay, so I have to make the connections. Okay, so I'm using these buttons to activate this circuit. Okay, so I will take a connection from here. We will connect over here. Okay, so after that, I will take another thing. Okay, I will connect this thing to a neutral. Okay, be cautious while connecting this thing. There should not be any red thing present over here. It is showing, if it is showing red, it is not getting connected. If I start the simulation, you can see if I click this button, you can see that there is a green signal is on. Okay, so it is showing that all the signals are, all the connections are okay. Okay, so I will connect the same thing over here also for another switch. Okay, and this goes to neutral. So these are the same like the banana lines we have. So student will get to know that thing. Okay, banana. So it is a same experience like the physical thing. So they can perform. So I will start the simulation. You can see if I click this button, it is getting actuated. You can see green button, it is getting actuated. Okay. And when I want to retract it back, I have to click on this movement push button. It will get back to its original position. So by using this thing, students can perform various operations. They can learn easily how the actual things are working, how the relays are, how the movement push buttons are, HMI buttons will look like, how these banana cables will get connected to each other, and they can perform the same operation to the hardware. So that's one of the most best thing. I will stop the simulation for this one. So we have completed the virtual trainer kit. If you have any doubt, let me know later on. So I will address those things also. Then after that, this is the technical training material. Okay, so this is the test. So whenever you install this software at your end, you will find there is a tab, technical training material. Okay, here you can find various tabs over here, various icons, just like the hydraulic, electrotechnical, pneumatic, automation, any technical books. Okay, so this can be accessed. So today we are mainly concerned with the pneumatics. So I will click on this pneumatic button. Okay, you'll see there is a catalog manager open. Okay, the catalog manager can be accessed through this icon over here from the home tab. Okay, so it is showing pneumatic list of activities. So it is showing that physics, components, and the circuits. Okay, door control, impulsion control. So all these things are present over here. So in the components, you will find, you can even do enlarge this thing for your greater view. You can customize as per requirement. All these things are customizable at your end also. Okay, So you can see in the physics, we will find Boyle's law, Charles law, Gassett's law, ideal gas law. So whatever the teacher taught in the class, or all these things, they can perform these operations using the Automation Studio. For the components we came, so there are the check walls. So simply they can click on this thing. Here you can find what they have. So they can simply open this thing through this PRX, already created PRX. Okay, and they can perform the operations. So same is applicable for accumulator, the sequence, linear actuators, reducing. So there are a lot of examples available for the teachers to teach and students to learn from here. Okay, just like the ready for the industry thing is available through this Automation Studio. So I'm going to take an example of Boyle's law. Here you can find the interactive thing also. When I open this thing, okay, so you can see I have opened this thing. So in this tab, you will find something: reload, pause, resume, skip, volume. So all these things are available to access. So during the simulation, you can pause the simulation, you can resume the simulation, you can make the speed of the simulation slow, stop the simulation. You can even modify the languages available from here. Okay, if you need the another language, French, Spanish, Portuguese, you can access those things from here also. Okay, so we have to start the things. Okay, so it is very interactive. So just have to click on the ready button. So there is a background noise, background voice from here. Okay, so you can listen that thing also from your side. Okay, and you can perform the same operations in the next step. Okay, just I will show you how it is, how it look like. So click.
In the following illustration, we'll try to understand Boyle's law using an experiment. In this experiment, we have a single acting cylinder, which is connected to a pressure source via a normally closed electric shut-off valve. A relief valve is also used to limit the system pressure. Activate the electric shut-off valve using the push button in the electrical circuit. The red dot shows the instantaneous pressure-volume relationship for the cylinder. Use the push button to extend the cylinder fully, and then release it when a pressure of 2 bar is available at the piston end. Observe the red dot on the graph to see the changes in the system parameters. Apply a load using the external load slider and see its effect on pressure, volume, and linear position of the cylinder. Answer the following questions based on the above test experience.
Okay, you can find this. There are some interactive questions also available over here. So students can go through that thing. So teachers can ask for the same thing in the exam also. They can check out the information or the learning thing, what the student has learned or not, that through this one. So if I click on this right button over here,
This experiment establishes
it is going to explain
relation
our,
between pressure and volume of a fixed amount of an ideal gas at constant temperature. In mathematical terms, this relation can be expressed as P is inversely proportional to V. By removing the proportionality, the equation could be rewritten as PV is equal to K.
so
V is the volume of the gas, P is absolute gas pressure, and K is a proportionality constant. To compare the same gas under two different set of conditions, the mathematical expression of the law can be written as P1V1 is equal to P2V2. It can be computed that the absolute pressure exerted by a given mass of an ideal gas is inversely proportional to the volume it occupies if the temperature and amount of gas remain unchanged within a closed system. Thank you for completing this exercise. Please refer the available complementary information containing the details of the actual experiment performed by Robert Boyle and its graphical outcome.
so this is the exercise can be performed by the students to know what they learned from this Boyle's law. So this is the interactive thing. The same is applicable for others. If you go to the catalog manager, you'll find same for the Chad's law, same for the check wall. You can see there are some interactive sessions available over here. So simply teachers has to run. So they will hear the sound from the background. So the tutor will ready to know that what is this check wall, how it is going to perform all these things. So there are some simulation operations are available. So all these things can be grabbed through this teachware. Okay, so this is one of the important thing for the teachers also and for the student also. Okay, so the next topic for us is demo files. Okay, so after learning all these things, you will like to know that, okay, I would like to know more and more things about the Automation Studio. How can I perform the advanced things inside the Automation Studio? So they can take the example of these things. Okay, how they are going to know that thing? So simply I have to go the Family Technology website over here inside the demo. Okay, so you can find there are so many things available already available. Okay, so robotics, electrical, PLC, hydraulic, pneumatic. So simply they have to click the sections and they will find the digital pin of portable trainer, electroneumatic A plus B plus, A minus B minus, electronic with animations. So all these things present for the students to perform the operations. So simply they have to click this download button. The PRX file will be downloaded at your end, and you have to simply run that PRX file inside this Automation Studio E9.0. Okay, so that's it's that much of your simple thing and useful thing for the all of the students and the teachers. Okay, after that, okay, so that's our end. So do you have any questions regarding this webinar? Anyone, please let me know. Manthan?
Yes. If anyone have any questions, you can type in chat box. We will address that.
For any contact, you can contact us. So there is a technical sense representative, Saurav Lakmapure. You can write down the mail ID. Today I presented this session, so you can write down my mail ID. You can mail me whatever the questions you have. Even though you can contact us through the FAMIC chat. Okay, so we have chat facility over here. Okay, if you go to here, you can type your message over here, and you can ask whatever the questions you have later on also. Okay, so there are so many ways to contact us, even though after this webinar.
Can there is one question?
Yes.
Can you can you paste the link of demo files link?
Sure, definitely. We will mail everyone for the demo link. Okay, so we'll get that thing.
Yes, the session recording you will get the recording directly on your mail ID.
Yes. Even though you can find the previous webinars also, if you want another webinars, if you miss that thing, so you can simply go to the Family Technology website, or here you will find all the webinars present. Okay, you can see the professional edition and education edition, the videos present for all these things. Okay, you can see interface overview, introduction to manipulation, and keyboard shortcuts, managing Windows appearance. So all these things are already present. And even though this webinar is getting recorded, so you will get the link for the particular thing also. Any more questions? Yes, Manta, I think so. There is no questions, any more questions over here. So we can switch to genetics.
Yeah, so I think there is no more questions. If still they want, we can communicate them through mail or other process. I
Yes,
think
yes,
we'll wind
definitely.
off the session, sir. Thank you for for the participants for attending the webinar today. So we have the PLC, the topic PLC tomorrow. So who are not registered, please go and register for tomorrow's webinar on topic of PLC. So thank you, FAMIC team. Thank you for the wonderful session.
Yeah.
Thank you, sir.